You are welcome to today's class, the second part of the general knowledge about physics practical. If you have not watched the part 1 of this class, kindly go to our channel and watch the part 1 first, because this is the second part of it. We have discussed, in part 1, about observation, how to plot our graph, how to determine our slope, and how to determine our intercept. In the second part of this class, we shall be discussing about how to deduct from our graph, how to evaluate, how to do precaution, and how to answer our short answers question. Now, let us assume that this is the graph that we have plotted. We have plotted the graph of K against M. Now, let us assume that this graph that we have plotted, in one of the questions given to us, the question says, from your graph. Anytime you hear from your graph, it's talking about deduction from graph. Let's say the question says, from your graph, determine the value of M when K equals 2. Determine the value of M when K equals 2. So what is the value of M when K equals 2? You will just go to the graph that you have plotted. You will locate your 2. Let us assume that this is your 2 on K axis. You will locate your 2 on K axis. You will now come to where the 2 is. You draw a thin continuous line to meet your straight line graph, the graph that you have already plotted, and you trace it downward. By the time you trace it downward to M axis, whatever you read here is the value of M when K is 2. So let us assume that when I trace it downward, my answer is just 5. So I will just say from the graph when K equals 2, M equals 5. That's just it. So let's go to evaluation. Let us assume that the question says evaluate P equals 2 pi S over C. 2 pi S over C. Now, P is what you are going to get the value. 2 is a constant. Pi is also a constant, which is 22 over 7. Our S is the slope that we have determined, and our C is our intercept. Now, you will just substitute the value of S, the value of C into this equation, and you find your final answer. So let us assume that the value of our C is 1, our C is 1, our S is 0.7, and we have been given the value of pi to be 22 over 7. Therefore, we now say P equals to 2 times 22 over 7 times our S, which is 0.7, all over our C, which is 1. Now, from that, which is 1, this is 1. Now, this is 7 here, 1. 7 is 0.7, that's 0.1. We now have 2 times 22 to give us 44. 44 times 0.1 will give us 4.4. So that's just about evaluation. Now, let us see how we can state our precautions in physics practical. What are precautions? Precautions are do's or don'ts to ensure accurate result while we are performing our experiments. Number one thing that you need to know about precaution is that it must be personalized. You were the one that handle the apparatus and you perform the experiment by yourself. So while stating your precaution, you must personalize it. You must use the word I. The word I. Number 2, it must be stated in past tense. It must be stated in past tense. By the time they are asking you to state your precaution, you have already performed your experiment. Therefore, it must be in past tense. For example, let's say you have performed experiment on mechanism whereby you have made use of stopwatch, a meter rule, a simple pendulum, and then you are asked to state your precaution. You can go ahead and say, I avoided droughts. In simple pendulum experiment, drought can affect the experiment, and you need to take note of the spelling of this drought, not this one. We have 2 droughts in English language. This one means lack of rain, and we are not talking about this one here. We can only talk about this one in agricultural science or in biology. Or now, this one is drought, wind blow, strong wind that is blowing. So you need to take note of the spelling of drought that we are considering here. Number 3 that you need to take note is that you must state the apparatus that you are using, and you state the error that is associated with that. For example, you can say, I avoided parallax error on stop clock. Yes, parallax error is an error that is associated with what? Stop clock. Or you can say a meter rule. Since you use the meter rule in the experiment, we have parallax error, we have zero error as well. These 2 errors are associated with meter rule and stopwatch. You can simply say, I avoided zero error on stopwatch. The last one is the short answer question that will be given to you. You will agree with me that the experiment that you have performed, you have been taught in the class theoretically before. Now they want to test your knowledge about the theoretical background that you have concerning the experiments you have performed. Like I said earlier, let us assume that the experiment is on simple pendulum. The question can say, define simple harmonic motion. Simple harmonic motion. Or the question can say, define period of a pendulum performing simple harmonic motion. The question can say, differentiate between period of a pendulum and frequency of a pendulum. So these are the little questions you may be asked theoretically. And then I remember in a particular year, the question says, sketch a simple pendulum and show where there is maximum velocity and maximum acceleration. So in that year, this is the particular point that we have maximum velocity, and this is where we have maximum acceleration. The same way, you may be asked to draw this simple pendulum and show where there is maximum potential energy and maximum kinetic energy. So the same way, we have maximum kinetic energy here, we have maximum potential energy here. So these are the little short answer questions that will be given to you in the theoretical question concerning it. So that's the end about the general knowledge concerning physics practical examination as WAEC and NECO are concerned. If you have not subscribed to our YouTube channel, please do so so that whenever we upload new video, you will be notified. Thank you.